This is a video on the complex roots of polynomials, and in this video I'm going to be focusing on cubic polynomials. So we've got a good idea how a cubic looks, and what I'd like you to start by doing is sketching each of the following situations. So can you sketch a cubic with 3 real roots, 2 real roots, 1 real root? Pause the video, make an attempt at these, and then play on and see how things go. So here are my sketches. A cubic with 3 real roots will go through the x-axis in 3 places. A cubic with 2 real roots, how am I going to do this one? Well, if I draw a line here, I'm going to have 3 real roots. If I draw a line here, I'm going to have 1 real root. I suppose I could maybe argue that in this scenario I've got 2 real roots, but actually I've got 1 and 2 repeating, so that's still 3 real roots. So actually it's not possible to draw a cubic with 2 real roots. So he is gone out of the mix. And finally, this is a cubic with 1 real root. Obviously this is just one version of how this might look. It's quite possible that this portion of my cubic could be below the x-axis, and then the x-axis might just intersect with the cubic once up here either. So I really only have 2 cases to consider. The case where I've got 3 real roots, which we've looked at previously in algebra, and the case where I have 1 real root, which is really what's going to concern us now in complex numbers. So here's an example. Find the roots of z cubed minus 7z squared plus 32z minus 60 equals to 0. Now there's kind of a clue in the question here, because since z is being used as the variable, it's most likely that I'm going to be encountering complex numbers at some point. So I won't be surprised if I see complex roots. Now, we've dealt with cubics before and how to solve them, and the beginnings of this question will be the exact same as what we did in algebra. So pause the video for a moment and see if you can remember how you begin to solve a cubic function. So I'm going to start by substituting various values in for z to see can I figure out one of the roots. And when I substitute in 3, I find that that gives me a result of 0. So that tells me straight away that I know that 3 must be a root of this cubic. Of course, now that I know a root, well, I also immediately know a factor of the cubic. And now that I know that z minus 3 is a factor of the cubic, I can divide it into the cubic. So I'm going to set up my array, and I'm going to put z minus 3 outside on the left. And I'm going to put z cubed and minus 60 into the first and last box. And I've just realised my video is incorrectly rotated, so you're having to twist your iPad around on the table. Sorry about that. Oh well. I'm going to go on with my division. So z into z cubed gives me z squared, and minus 3 into minus 60 goes plus 20. So I can fill a bit more information out into the inside of my array. I'm able to fill in my minus 3z squared and my plus 20z. And then to fill in my middle column in my array, I'm going to go back and have a look at the 2 middle terms in my cubic. And since like terms in the array are on the diagonal, I'm expecting this to be a z squared term as well. So I want to make minus 7z squared. I've got minus 3. I'm going to need minus 4. And similarly, I want to make 32z using these 2 diagonals. So this must be plus 12z. Now this allows me to fill in the middle term in my quadratic on top. And don't forget that no matter which row I choose to use for division, I should get the same answer. So in this case, I get minus 4z, and that works no matter which row I'm going for. So at this stage, I've got my linear factor z minus 3 and my quadratic factor z squared minus 4z plus 20. To get the 2 other roots of this cubic, I'm going to have to solve this quadratic factor. Now, because of the z, I'm kind of thinking it's probably going to be unlikely that I can factorize this. And in fact, it does turn out to be impossible to factorize this quadratic. So my alternative route is going to be to use my minus b formula. Here it is. So in this case, z will be equal to this calculation. And then after a bit of tidying up, we're going to have 4 plus or minus the root of minus 64 over 2. Now, of course, the minute I see that root of minus 64, it lets me know that I'm going to be dealing with a complex number. So I'm going to split up that minus 64 into its factors of 64 and minus 1, which will then allow me to evaluate my complex roots. My last step along this way is going to be simply to divide by 2. And notice that this gives me two results really, 2 plus 4i and 2 minus 4i. And again, note that these two results are conjugates of one another. Now this isn't surprising, because if I think back to my original cubic, I note that all my coefficients were real numbers. So I expected conjugate roots. I'm going to finish the question by just listing out my 3 roots. And they are z equals 3, z equals 2 plus 4i, and z equals 2 minus 4i. Here's a second example. In this case, my cubic has a complex root of z equals 3 plus 5i, and I want to find the other 2 roots. Pause the video at this stage and see, can you make an attempt at this yourself? Okay, so note that first of all, I can see that my cubic's coefficients are all real. That lets me know that I definitely have complex conjugate roots. So straight away I know that z equals 3 minus 5i is a root also. Now that I have these 2 complex roots, I could, if I wished, create the quadratic factor of the cubic by first of all converting these 2 roots into factors. Now I'm going to multiply these out using the array, and that'll create my quadratic factor of the cubic. So here I'm setting up my array, and now I'll proceed to multiply out. My completed array looks like this. And again, note the symmetry that we spoke about before. So I'm going to be able to cancel off a number of the boxes in my array. And of course, I've got that I squared down the bottom right-hand corner to watch out for. Remember that I squared equals to minus 1. So I'll work out my quadratic factor, which turns out to be z squared minus 6z plus 34. Now, I know that if I divide this quadratic factor into my original cubic, I should get my linear factor, and that'll then give me my final root. So again, off I go to draw out my array and do my division. And again, pause the video at this stage and see, can you manage that yourself? So here I've set up my array, and I'm going to write my quadratic factor across the top, and I'm going to fill in the first and last terms of the cubic inside the array. And at this point I'm almost home and dry. I want to just complete my division. So z squared into z cubed goes z, and 34 into 68 goes plus 2. I'm just going to complete the rest of my array just to be sure that nothing's after going funny. And I can see that once that's completed, I'm happy that it works, because 2z squared minus 6z squared is in fact that minus 4z squared, and 34z minus 12z is that 22z, so that worked out fine for me. So now I know my linear factor is z plus 2. And all I have to do to find that last root then, is let that linear factor equals to 0 and move the 2 across the equals. And then just to finish up, I'm going to list out my 3 roots, because that's what the question wanted, so I'm going to just make them very clear at the end of the question. And I'm done.